In this video, I am discussing about color models in computer graphics. A color model is an orderly system for creating a whole range of colors from a small set of primary colors. There are two types of color models, those that are subtractive and those that are additive. Additive color models use light to display color, while subtractive models use printing links. Color perceived in additive models are the result of transmitted light, and color perceived in the subtractive model are the result of reflected light. There are several established color models used in computer graphics, but the two most common color models are RGB model, which is red, green, blue, and the second one is CMYK model, cyan, magenta, yellow, black. RGB is an additive color model, as I have already said. For computer displays, uses light to display color. Color results from the transmitted light. That transmit light, such as television, use additive color mixing with primary colors of red, green, and blue, each of which stimulates one of the three types of the eye's color receptors with as little simulation as possible of the other two. This is called RGB color space. Mixtures of light of these primary cover a large part of human color space and thus produce a large part of human color experiences. This is why color television sets or color computer monitors need only produce mixtures of the red, green, and blue light. Other primary colors could in principle be used, but with red, green, and blue, the largest portion of the human color space can be captured. Here we see we get white color by mixing red, green, and blue. In CMYK color model, it is, I have already said that it is a subtractive color model and used for offset printing for the full color documents. Because such printing uses links of these four basic colors, it is often called four color printing. Where the two colors of RGB overlaps, we see a new color formed by mixing of the two additive primaries. These new colors are a greenish blue called cyan, a bluish red called magenta, and a bright yellow, and the key color is black. CMYK color model we can express the effect pseudo algebraically. Write RGB for red, green, and blue, CMY for cyan, magenta, yellow, and W for white, and using the plus sign to mean the additive mixing of the light and minus sign to mean the subtraction of light. We have cyan is equal to green plus blue is equal to white minus red. Then magenta is equal to red plus blue is equal to white minus green. And we get yellow is equal to red plus green is equal to white minus blue. The process of reflection, when we talk of cyan ink, we mean the ink that when it is applied to white paper and illuminated by white light will absorb the red component, allowing the green and blue, which combine to produce the cyan color to be reflected back. If we apply a layer of such an ink to white paper and then add a layer of yellow, the yellow ink will be absorbed and the incident blue light, so the combination of the cyan and yellow inks produce a green color. Similarly, combining cyan and magenta inks produces blue. A combination of the three colors will absorb all incident light and producing black. This is the pictorial representation of color model RGB and CMYK. These subtractive primaries are the primary colors which the artist working in conventional media must use. Besides, the range of the colors that can be produced by mixing of primary colored paint, combining actual links of all three colors does not produce a very good black. On the top of this, applying three different inks is not very good for the papers and that leads to longer drying times. For these reasons, in magazine and book printing, the three subtractive primaries are augmented with black. The CMYK gamut is smaller than RGB but is not a strict subset. There are CMYK color that fall outside of the RGB gamut and vice versa. Thank you.